For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Okay, looks like we are live, guys. And this is an extremely exciting event that we have today. We have Michael J. Oard with us for a presentation titled Astounding Evidence for Noah's Flood. We will also be having a question and answer period, okay, following the presentation. Please share around. I promise you this is going to be one to remember. The question and answer is going to be not only from us as the hosts. I've got George here as well. But also from our awesome audience today. So please make sure you are tagging me at Standing for Truth or at George Bond, just to make sure that we see your questions and we can save them for Mike. Now, before I go over a brief introduction into who Mike Oard is, I first want to thank him for giving us his time today for this incredibly important show. So I'm going to bring him into the stream as well as George, our awesome co-interviewer here. Mike, thanks so much for being so generous with your time and giving us your time today.
You're welcome.
Yeah, really looking forward to this. So real quick, I'm going to go through a brief introduction, Mike, and of course, correct me if I'm wrong on any of this. So Mike Oard has an MS degree in atmospheric science from the University of Washington. After 30 years as a meteorologist with the U.S. National Weather Service, he retired and now is fully devoted to research on the compelling evidence for Noah's flood and the post-flood ice age. He has done considerable study on the woolly mammoths in light of Noah's flood and the ice age. Mike has published several research papers in his field in journals of the American Meteorological Society. His creationist research has been published in technical books, layman's books, and children's books, as well as in many creationist journals. He also lectures on these subjects and serves on the board of directors of the Creation Research Society in the U.S. I'm also happy to say I've got George here again with me for this show. So George, thank you for being here.
Thank you, SFT. Firstly, Mike, I'm Australian. We don't have an accent. You guys have an accent.
Okay.
Firstly, I want to point out that the information provided by SFT can be found in the description box. I urge you all to go and have a look at it. There are some links there to his Genesis website, I believe, his own website and many others. As we said, his website is linked in the description box, so please have a look. He has a number of books and videos which are excellent, by the way. SFT and I have read some of his papers and watched his videos on YouTube. He's a wealth of knowledge, especially in the area of the Ice Age, coming from the MS degree in atmospheric science. Mike, we like to be a little bit lighthearted on this channel, and we like to start with a few jokes. So I hope I don't turn you off by some of them. Okay.
Okay.
I'll start off with the first one. If you were in a freezing room and want to stay warm and comfortable, you should always stick to the corners, because they are all 90 degrees.
Good. I never heard that one before.
Oh, well, I hope you haven't
never heard
this
that one either.
Someone told me, I can associate with this one, by the way. Someone told me I could make ice cubes out of leftover wine, but I'm confused. What is leftover wine? Anyway, I hope I haven't discouraged you now. You must be thinking, what on earth have I got myself into? So I'll give it over to you, Mike. So yeah, I believe you've got a fantastic presentation for us, and I think SFT will share your screen and let's go.
Okay.
Yes, let me get your screen going, Mike.
Okay.
Okay, here we are.
Am I good to go?
Yep.
You're all good to go, Mike. Screen
Okay,
looks
my
good.
topic is Noah's flood. Actually, an issue I've been working on for 45 years with research, besides the Ice Age. Anyway, this title is Astounding Evidence for Noah's Flood. What I'm going to give you is just a summary and just the highlights of the summary of all the details you can fit into the what can be called as the flood model. But you know, there's a lot of secular researchers and even some Christian geology professors who say there isn't any evidence for the flood. Here's one from Davis Young, retired professor of geology from Calvin College, in a book titled, of all things, The Biblical Flood. He says, there is no geological evidence to confirm the idea of a universal deluge. Boy, isn't that an amazing thing? And I'm going to go back to that towards the end and kind of have a suggestion of why. I'm going to talk for maybe about 45 minutes, an hour, and I'm going to open it up to questions and go from there. Anyway, when I hear challenges like that, and by the way, I try to keep up with 50 earth science journals in the local library here at Montana State University. And I run into challenges all the time in the earth science, but I see them as just research opportunities. But when I look at these secular articles, I glean the raw observational data from their interpretations and I separate them. I'm looking for the real raw data. That's the science that I'm looking for. And I go from there. Anyway, this is my theme verse for research. It's a good theme verse for all of life. Examine everything carefully, hold fast to that which is good. 1 Thessalonians 5:21, New American Standard Version. I can't emphasize carefully enough, because if you examine an issue just superficially, you might know enough just to get into trouble. You got to go carefully, dig. So I dig into the research, and then that's how from there I write my articles and books. So anyway, I want to start with this graph. When we're talking about the flood, I want to first of all say a little bit about what was the pre-flood world like before the flood. And we have some clues, not only from the Bible, but from geology and the fossils. One big clue is that the estimated amount of coal in the earth is about 10 times the amount of carbon than in the current biosphere, meaning that we probably had about 10 times as many plants and trees on the pre-flood earth. And there's hardly any frost rings, if any. So it's a warm climate with a huge amount of vegetation before the flood. And the interesting thing about vegetation is it gives off water vapor, transpiration. 10% of the rain we get on the continents is from transpiration through the leaves of trees. And so they'd add a lot of water vapor to the pre-flood earth. So we can, from that, we know we're going to have a pretty good greenhouse effect. And we need to water all that. So we had a different hydrology. There's a question whether it rained before the flood. I kind of lean that it did, even though it's uncertain from the Bible. And I must say that we don't know what the geography was before the flood and the topography. They were both much different. So we don't know those things. One thing from my field, it doesn't look like there's a vapor canopy, as some people thought in the early days of creation research, due to the research of Larry Vardaman. It'd be too hot on the surface of the earth. It's plain and simple. And so that's a big problem. I haven't given up on it. You might be able to tweak it with a three-dimensional computer model with clouds and so forth. But my hope isn't up. Anyway, I don't do anything more than that. But we had the pre-flood Earth. We have some clues from the fossils and the amount of coal. Okay, when we look at just the Bible, we can kind of diagram the flood. Like any flood, there's a rising stage called the flooding stage and a retreating stage. And all floods are like this. So if we use that, we can realize that it appears that even though there's controversy over it, the flood peaked at day 150. That's generally the most common view, and I subscribe to it. And so during the flooding stage, we can divide it up into two phases. And each phase that you see at the top up here on my screen produces different signatures in the rocks. And so the first phase, by the way, this comes from Dr. Taz Walker from Creation Ministries International in Australia, who first reported on this in 1994 at the International Conference on Creationism, and I subscribe to it wholeheartedly. And based on this template, I've been able to see things from this point of view and see just a tremendous amount of evidence for the flood, which I'll just be summarizing for you. So two phases. The first phase is probably the most violent, when the mechanism of the flood erupts. And the fountains of the great deep and the windows of heaven opened, and the result of these were rain for 40 days and 40 nights. So that first phase probably was 40 days, and then it lessened and the rain lessened, and so we went into phase 2, which is a general rise. In phase 1, it was probably a rapid rise, lots of turbulence, fast currents. I'm not going to talk much about the mechanism. I lean towards a particular mechanism, but there's several models of flood mechanisms out there. But this is kind of doesn't depend on any one particular flood mechanism. This is just a diagram from the Bible. We should look at the rocks from the point of view of the Bible. That's the beauty about what Taz Walker does, not from assuming the geological column, for instance. And a lot of times they line up anyway, but sometimes they don't. Anyway, the first, I think Taz Walker calls it the eruptive phase. So it's about 40 days, I think, and then it tailed off, and you had a gradual rise of the floodwaters. Phase 2, called the ascending phase in Taz Walker's terminology. Now, during that ascending phase, you had a lot of oscillating currents due to tides and about 4 other mechanisms I can think of, and a gradual rise. So we had gradual sedimentation with cyclical sedimentation going on, forming coal seams and other cyclical depositional patterns that you see commonly in the rocks. So the flood peaked at day 150. And this was the time when all that breathed there and lived on land died, and all the sediments were deposited, and the fossil and the organisms were in the sediments that turned to rock. Pretty quick. Cementation is a very interesting, difficult thing. I've been working on it for the last couple of years for sand, and it's very complicated. But anyway, during the flood, you can cement these sediments pretty fast and fossilize the organisms at the same time. So that's where all the strata fits, right in there. And not only all the strata we see on the continents today, we have an average of 1,800 meters of sediment, about 6,000 feet average. But at the peak of the flood, based on the amount of sediments that ran off during the retreating stage, which I'll get to, there was actually about twice as many sediments on the continents as the 1,800 meters we still have left on the average, about 3,600 meters. So we have to develop 3,600 meters of sediments on all the continents average. And just on the continents, which is not on the ocean basins, which is very interesting, but they're making me think about a lot of things to add to this flood model in the future. So at the peak of the flood, Psalm 104, verse 8 says, the mountains rose, the valley sank down. So you had differential vertical tectonics starting at phase 3, the peak of the flood. And when that happens, the floodwater's running off, the retreating stage. The continents are coming up, the ocean basins are sinking. And during phase 4, the currents are very wide. There's hardly anything exposed. Nothing's exposed except, nothing exposed at the peak of the flood. Then finally more mountains and plateaus were exposed with time. But for a while, nothing was there. And so you had big, wide currents moving at high speed from off the continents, just eroding a huge amount of sediment. And there's evidence for this all over. I can show you big chunks of where sediment's been eroded off. I've done a lot of erosion studies on the continents, and I get huge numbers of erosion in many places. Southeast England, for instance, Southwest Africa, the Colorado Plateau, the Appalachian Mountains. I get huge numbers. And from a new paper in the journal called G-Cubed, which stands for Geochemistry, Geophysics, Geosystems, it's a journal of the Geophysical Union. And they know now how much sediments ran off that are in the ocean basin, especially along the edges of the continents, where where you'd expect the deposition from all the continental erosion to end up. So, and that's where I get now that there's probably 1,800 meters were eroded off the continents on the average. Remember, we're talking about the average. So you had what's called, phase 4 is sheet erosion, and certain features affected the surface of the earth during that. And from the field of geomorphology, the study of the surface features of the earth and landforms, we can see these features, what happened during what's called the sheet flow phase. Sheet flow means big, wide currents and not very deep, kind of the consistency of a sheet. Like a current might be 2,000 kilometers wide and 10 kilometers deep. So it's very wide and not very deep. It's like a sheet. So you had sheet flow eroding as a sheet, the sediments, and depositing them as a sheet along the continental margins that are now the continental shelf and slope. And then as more mountains and valleys show up above the floodwaters are forced to channelize, go around these, and they mark the surface of the land with different landforms due to channelized erosion during phase 5. And I'm going to show you examples of all these phases from now on. Anyway, these are slides from a talk I normally give, but I'm skipping number 1. This is evidence from strata, which is a geological jargon for sedimentary rocks. So a good place to see strata is Grand Canyon, mile deep cut in the earth. And you see the strata, it's about a mile deep or 5,000 meters deep. And you notice several things here. You see these what they call formations, rocks that are similar, and you can trace them for mostly across the 200 and some odd miles of the canyon. Like there's a bottom layer here called the Tapete Sandstone. I'm going to make a point of that coming up. And so you have these layers, and we can trace these layers at other locations in North America. Also, we see one layer, one on top of another, with little or no erosion between them. Yet the secular scientists say that this deposition here in Grand Canyon, from the bottom to the top, represents 250 million years. Okay, I'm going to get back to that. Another thing you see at Grand Canyon is that flat surface up there. Wow, you can be going along hiking in a flat surface and all of a sudden see this huge chasm. It's quite breathtaking. And if you've never been there, you should visit it. Anyway, this flat surface is a planation surface, which I'll talk about when I get into the section on geomorphology on the runoff. Now, that surface represents the erosion of about 3,500 meters of strata as a sheet taken off the whole Grand Canyon area. We know this because we see the strata in Utah to the north, about 100 kilometers, 150 kilometers to the north, where it's dipping down to the north and a series of steps called the Grand Staircase. And all that strata used to be up over the Grand Canyon area, about 3,500 meters, and it's been eroded off the whole area, forming a planation surface after it's eroded. So I'm going to talk more about that later. But anyway, here's the Tepete sandstone. It's a very unique sandstone, and it has a unique position. It's on top of the granitic and metamorphic crust, upper crust of the earth, of the continents. So it's a unique location. It's a unique sandstone. It's coarse grained. You can see some of the coarse particles in it. And sometimes you might call it a conglomerate. There's so many quartz grains in it. Small cross beds. It's about about 80 meters thick on the average. It varies some. But anyway, we can trace this same sandstone over half of North America, believe it or not. Up in my area, about 150 kilometers north of Grand Canyon in Montana and Wyoming, we see the same sandstone, but it's given a different name because the researchers didn't know they were connected. So up in my area, it's called the Flathead Sandstone, and it sits on top of granite of the upper crust. And here it is right here at Cody, Wyoming. Same coarse grained sandstone, and on top of granite of the upper crust. And when you trace it all out, this is where you find it. Most of it's below the ground in the Midwest and towards the Appalachian Basin. And it occurs up in Canada through the Rockies and up into Northeast Canada, up in the Queen Elizabeth Islands. So it covers about half of North America. Now I want to ask you and it's generally about the same thickness too, 80 meters about. Doesn't deviate a whole lot from that, but it does deviate some. I ask you, if we assume that all this sedimentary rocks was deposited by slow processes over millions of years, which is the secular uniformitarian idea, how are they going to deposit a sand on top of the upper crust of the earth over half of North America? That makes no sense, because deposition today is sand and it changes to clay, mud, gravel in short distances, both horizontally and vertically. It's a mess. And you wouldn't have something like this, not at all. This totally defies secular uniformitarian geology. This is exactly what you expect in Noah's flood, where we had layers laid down over huge areas, one on top of another. And so we're going to get back to the lack of erosion and the layers in here. 5,000 feet, or about 2,000 meters or so, something like that, 1,700 of sediments. They say 250 million years. But you know, erosion on a million-year time scale is huge. So huge that all the continents can be eroded to sea level in only 10 million years at today's rate. But there's some caveats on that, because man has caused some of this erosion, so you got to deal with that. And as the mountains decrease in height, the erosion rate decreases too. But it does not include coastal erosion, which is generally about 7 meters a year along the Arctic coast. But you can put a maximum on this of 50 million years to wipe out the continents to sea level. If erosion is that fast, then where's all the evidence of canyons and valleys in the walls of Grand Canyon? They're not there, indicating that one layer is laid rapidly, one on top of another, with no millions of years involved at all. So here's a little schematic of the Grand Canyon. Let's say this is just for 1 million years. And here we have the bedrock of the upper crust, and we have 4 layers deposited over the whole Grand Canyon area, 200 and some odd miles. Then we'll give it, say, 100,000 years of time, and this is what would happen. You erode valleys and ridges. And then suddenly it will say it dropped below the sea, and you had more layers deposited. They'd fill up the valleys like this with more layers. And then you do it for another 100,000 years exposure, and more valleys are cut, and so forth and so on. This is sort of what you see. If it's just 1 million years, or maybe just 100,000 years, you should see huge amount of valleys and canyons in the walls of the Grand Canyon, especially since the uniformitarians claim that these layers, these formations, are a lot of times terrestrial formations or shallow marine formations. Usually that, and in those environments, you'd expect a lot of canyons and valleys to be cut. But this is normally what we see in the Grand Canyon, generally layers that don't change thickness all the way across, but some layers will change thickness a little, pinch out, few pinch out, and that defies secular science. And we see this pattern everywhere where we see sedimentary rocks. We see layers. The deformation or the breaking up of those sedimentary rocks occurred after they were all laid down. Then you had faulting and erosion of them, but they're laid down generally without little deformation at the start. And up in the Grand Teton Mountains of Wyoming, I got a book where 3 geologists admitted this. So here's a sequence of sedimentary rocks right in here, one layer on top of another. That's the top of Grand Teton Mountain, which is granitic or gneiss that's been bowed up, but on the north and south edges, the sedimentary rocks were not washed off. And here's a thickness of about 3,000 feet, or about 900 meters. That is almost the same as in the Grand Canyon, 1,000 kilometers to the south, same sedimentary rocks up here. And there's one layer right after another. This represents maybe about 190 million years in the secular time scale. Anyway, these 3 geologists in this book, The Chronicles of Jackson Hole and the Teton Range, said the regularity and parallelism of the layers in well-exposed sections that I just showed you a picture of suggests that all these rocks were deposited in what? A single uninterrupted sequence. Yes, that's what they say. That's what it's you look like. That's what we observe. Do they believe it? No. You say, however, the fossils and regional distributions of the rock units show that this is not really the case. They go to their theories of deep time, the millions of years, stretch out everything. The incomplete nature of the stratigraphic record becomes apparent when the spans of time represented by each of the various formations are plotted on the numerical time scale. And this is their time scale. Most of it's missing time. The blue is the time for the formations. And here's the formation names up here. Here's 80 million years missing. Here's their time scale right here, 500 million up to 300 there. And I might add that when you look at these individual formations, it looks like maybe this one was deposited in 10 million years, but you find out that even these formations are full of gaps of time. So you should see little white areas all through these formations, so that when you add it all up, and secular scientists admitted that, they only have 1% of the record of time, 1% about. The rest, 99%, is totally missing. And the important thing is there's no erosion between these layers over about 180 million years. The Flathead Sandstone being the bottom formation in the Cambrian, on top of the Proterozoic granites and gneiss of the upper crust. So evidence from fossils. Now I might add that when we talk about Grand Canyon, I put the deposition of Grand Canyon and practically all the sedimentary rocks in phase 2. I believe phase 1, when the mechanism was unleashing turbulence and a lot of chaos, but not everywhere, that you form deep basins. And so the only sedimentation that occurred during phase 1, I believe, is in deep basins, forming your Precambrian sedimentary rocks, which I have come to believe are from the flood. Why? Because up in my area, here in the Northern Rockies of Montana, I'm privileged to be next to one of the biggest Precambrian formations in the world called the Belt Supergroup. And that Precambrian formation, dated 1.5 billion years according to the secular timescale, is conformable to the Flathead sandstone right above in numerous places, as if there's no change in sediments. And it's just one big deposition from the Precambrian up in through the Cambrian and the Ordovician and all the other rocks that you see on top of it. So that's, to me, pretty good evidence that the Precambrian sedimentary rocks are from the flood. And it's interesting, practically all Precambrian sedimentary rocks are found in what were used to be basins, deep basins, like the Belt Supergroup was deposited in a basin 25 kilometers deep, big hole. I think it's an impact crater, and so do 2 other secular scientists, filled up rapidly with sediments coming from the west off the current Pacific Ocean, I might add. A lot of details can be filled in, and I'm kind of doing this as I go because there's a lot more research. I'm just giving you a quickie summary. But so this, I think the real sediment that started in the Cambrian, the flat sediments with little deformation, as you saw in the Grand Canyon, they had to be deposited during a calmer period of the flood. And I think it was during the ascending phase when the chaos of the flood, of the mechanism of the flood lessened a lot, so that all the churned up sediments, instead of moving in the water column, which is probably very deep, now settled out. And in all of those sediments, we have fossils. And, you know, when we look at the details of fossils, they're strongly against uniformitarianism and show the flood. First of all, how to form a fossil? Well, you have to bury it rapidly. So that's one thing. Not only must it be fossilized rapidly before decay sets in. And right now, fossils are hardly ever forming. You can form them in hot springs areas with a lot of silicon dioxide. But even that is rare. There's hardly any fossils being formed up near Yellowstone Park, where I live near, due to all the hot springs and the silica and carbonate in those hot springs. And chemicals must be forced into the bones and shells rapidly. That's a pretty tall order, and that's one of the main reasons why fossilization is extremely rare today. And yet we have billions, if not trillions, of fossils out there. That's why I think Ken Ham's statement really has a lot of wisdom. He says, billions of dead things buried in rock layers laid down by water all over the earth. Evidence for the flood. It's exactly what we see. And not slow process of deposition. You can't form fossils that way. And we have these monstrous fossil graveyards. Here's a unique fossil graveyard from Venezuela of ammonite fossils. And then up in my area, we have a lot of dinosaur graveyards. North of me, about 150 kilometers, is a graveyard of 10,000 duck-billed dinosaurs, all of the same species, I might add, with no babies or young juveniles, all older adults and older juveniles, which is an unusual feature. There's a number of unusual features on that dinosaur bone bed. But there's a number of other bone beds in Alberta and some in Wyoming. There's lots of dinosaurs around here. That's why I've written one children's book on dinosaurs and one layman's book on dinosaurs. And we also have indications of rapid fossilization, fish eating fish in various locations, and an ichthyosaur that was fossilized in the process of giving birth. So these are indications of rapid deposition. But one of the strongest evidence of rapid deposition all over the world are mollusks. 95% of fossils are mollusks, like clams, and that'll include brachiopods and oysters. And anyway, it's interesting. Most mollusk shells, when you find them as fossils, are closed. But when a mollusk dies, the muscles that keep the shell closed detach, and it opens up quickly and it decays, because even the shell is made of partly organic matter. So it takes days, maybe weeks, for the shell to open up. The fact that we have so many closed shelled mollusks all over the world indicates rapid deposition globally. And here's a sample from Washington State, where I was raised, Seattle, Washington. And these are clams, brachiopods, and oysters found in just fossils in Washington State. Okay, now we're going to transition to evidence from geomorphology, the study of the surface features of the Earth. There's a whole lot of surface features that defy uniformitarianism. They can't explain them. And let's go back to this diagram. I've talked about mainly, especially phase 2. That's where most of the deposition occurred on the continents, and even twice as much as we see, as I found out. And by the way, this is a recent discovery I made about the amount of sediments that were eroded off. But we're going to transition to the retreating stage. The waters are running off the continents. The continents are rising, the ocean basin's sinking. Just think of the potential energy where you have water pushed up and then water going down. You can have tremendous movement of the currents and causing tremendous erosion, which we infer from a lot of indications in the sedimentary rocks. There's a lot of ways to determine the amount of erosion, and I'm working on one research project that we hope to send out to the Creation Research Society here soon on the cementation of sandstones that give you an indication how much pressure of sediments were above that were eroded, to explain the thin section analysis of these sandstones. So the retreating stage. So I'm going to start with phase 4. And I'm not going to talk about all the evidence for the mountains rising, the valley sinking down. Lots of evidence for that. So that's a whole different subject, but we'll just transform into the landforms, the geomorphology part of it. So phase 4. So here's a block diagram I made quite a long time ago when I didn't know how much sediment eroded off. And here's the peak of the flood at day 150 would be this area up in here. And this represents all the eroded strata, retreating stage erosion. This is the current continental surface with a nice dinosaur fossil there at the top. And this is the current continental sedimentary rocks, 1,800 meters average. So I figured this is maybe 500 meters, even though in a lot of areas I was getting some big numbers. There's a lot of areas that look like they weren't eroded a huge amount. We don't know, because there's no erosional remnants or eroded anticlines to determine how much erosion. But there's other ways. We can tell from sandstone and the rank of coal generally too. And Peter Kleberg at Great Falls, Montana, and myself are working on this topic. But because of this new paper I discovered a couple of months ago in the scientific literature, this should go up as high as this right here. The amount eroded is the same as that, approximately the same as that left. Not 500 meters, but 1,800 meters were eroded off the continents. Wow. That is huge. And as it eroded, it left on the surface of the continents that we can see today various features of this erosion that the secular scientists cannot explain, even though they've been trying for at least 150 years. So the first one we're talking about is planation surfaces. I showed you that one in the Grand Canyon area. I think I might have another picture of it here unless I deleted it. I have lots of pictures of planation surfaces. So let's first of all define what a planation surface is. Well, I have to go to an erosion surface. Erosion surface is, in the dictionary of geological terms, a land surface shaped and subdued by the action of erosion, which is really not saying too much, but especially by running water. What they're telling us is that the land surface has been shaped by erosion by running water. Oh, and that's kind of sounding like runoff of the floodwaters. Why do they say running water? Because a lot of these planation surfaces have rounded rocks on the top of them, left over after they rounded the rocks, and as the current slowed, it deposited what the stones that were being used to erode the surface. Rounded rock. I'll show you some pictures of all this. The term erosion surface is generally applied to a level or nearly level surface. Now, erosion surfaces can be kind of rolling, but a planation surface is generally dead flat, almost flat as a pancake. And I'm going to just mainly talk about planation surfaces because they're more so distinct. And here's one in north central Wyoming, in the Bighorn Basin, which is about 200 kilometers north-south and about 100 kilometers east-west. This is the northern part. You can see this sedimentary rocks dipping to the west. That's to the right here. I'm looking south. It used to probably be a area bowed up there and just sheared off, forming a planation surface and forming about 15 feet of rounded rocks, which are over here too. It continues over here. But it's been dissected by either late flood channelized erosion and or post-flood river erosion. So it leaves this as a small erosion surface. So up in my area and in adjacent Canada, it's the plains consist of about 4 levels of planation surface in relation to the Rocky Mountains, which are over here to the west. This is the high plains of Alberta, Saskatchewan, northern Montana, part of North Dakota. And it has generally 4 levels. We found out it was a simplification because this level right here, called the Wood Mountain Plateau, is in between the top and the second from the top, this green area. Anyway, this is the Cypress Hills right here. This is a continuation, Swift Current Creek Plateau. I'm going to emphasize mainly the Cypress Hills Plateau because it's the highest one. This west end sticks out 2,500 feet above the river to the north, the South Saskatchewan River, and the river to the south of Milk River. 2,500 feet high above the rivers. And it was probably continuous in here. It's about, here's the scale here, 100 kilometers. It's about 120 kilometers long and probably was continuous before late flood channelized erosion eroded it and or river floods from the Ice Age melting, catastrophic river floods. It's called the Cypress Hills, and it's probably about 20 kilometers wide on the average. Probably was continuous at one time. It's a high planation surface, dissected. Many planation surfaces are dissected. These are all planation surfaces right in here. This is the next level. It's been tremendously dissected into isolated, semi-isolated plateaus called the Flaxville Plateaus. All these plateaus in here, and even the ones lower down in this area, are covered by rounded quartzite rocks. And here's a rose diagram right here from the direction where the quartzite came from. You see directional indicators in the quartzite as well as in the interbedded sandstones. And this one said that the rocks that are found on the top of this Cypress Hills, as well as all these plateaus, came from the west-southwest. Another report said the southwest. Well, if we go down to the southwest, we go down to here. The nearest outcrop where you find bedded quartzite rocks is in central Idaho. And this is acknowledged by secular scientists and Peter Kleberg and I that have studied this extensively. Came from central Idaho. All these quartzite rocks on here came from central Idaho. I'm going to talk about quartzite rocks next after planation surface. So let's take a picture. Here's the Cypress Hills, the northwest part, your Reeser Lake. Here's the central part right here. Here has been dissected by a glacial river because I found huge erratic boulders of continental shield rocks in here, indicating ice age erosion. And here's the eastern part of the Cypress Hills right here, all flat as a pancake. You drive up on it, and that's what it looks like, flat as a pancake. And then when you drive to the north edge, here's another planation surface. I'm going to talk about the quartzite rocks driving to the north edge soon. This is that planation surface in the Grand Canyon area. Probably about 300 kilometers east-west and about 200 kilometers north-south, the area where it's eroded as a sheet, forming this planation surface. Here's the north rim of the Grand Canyon. I assume everyone can see my cursor, and the Grand Canyon's between in there. But anyway, that's a planation surface. I'll talk about the quartzite rocks when I get to that session. Anyway, all planation surfaces were once much larger in the flood, but they got re-eroded and faulted different altitudes and broken up so that now we just have remnants of these planation surfaces. Anyway, Lester King said that these planation surfaces, which is evidence of runoff of the floodwater as a sheet flow, phase 4, were once huge on all the continents, exactly what we expect during the flood on all the continents, runoff. He says a planation of extraordinary smoothness developed over enormous areas in all the continents. From it, most of the world's present scenery has been subsequently been carved by renewed erosions. Yeah, after it was formed, it got broken up, eroded into remnants, and partly destroyed, forming mountains. A lot of planation surfaces are at the tops of mountains. Here's a planation surface in north central Montana, flat as a pancake. They even have an airport to the left there that's not in the photo. And what we observe with planation surfaces today, they're being eroded, they're being dissected. Like this one, it's being eroded from a stream coming out of the mountains to the right, the Little Rocky Mountains. That's what we see. Planation surfaces are being destroyed, not being formed today. And here's what we expect based on uniformitarian erosion. It'd be slow over millions of years. So in dipping sedimentary rocks, which are fairly common on the surface of the earth, we have generally hard rocks and soft layers. The hard layers would end up as ridges, and the soft layers would be eroded with some of the erosional material left in the valley, unconsolidated sediment. That's what we should see everywhere if uniformitarianism is true. We should see no planation surfaces because they're not forming today, except where a river will come out of its bank and erode tilted rocks and can form a flat surface, but that's only local, very local. So we don't see that this today. Well, actually, we do see a little bit of this, and this can be formed by slow currents. But this is commonly what we see. Both hard and soft rocks sheared off the same, implying a very fast current, leaving rounded cobbles and boulders on the top. That's commonly what we see. So, summary, they're not forming today, they're being destroyed. They're against uniformitarianism, they should not exist, but they're not only common as erosion remnants, we have indication they are once much more extensive on the continents. They're worldwide, difficult, if not impossible, to explain by slow processes over millions of years of erosion, powerful evidence for the global flood. So I'm going to get into the second sheet flow, phase 4 landform. It's not quite a landform, it's more an erosional feature and depositional feature. The quartzite rocks spread hundreds of miles from the source. Now, a quartzite is a metamorphic sandstone. After you form a sandstone, you cement the sand, you have to bury it deeply in big, deep holes, and you have to heat it up to about 500 degrees centigrade. And what happens is since the sand is mostly quartz, you recrystallize it and it forms a kind of a glassy texture. I think I have some pictures here. If not, I have lots of pictures, but only so many I have here. And then after it's buried, in fact, I don't think it was buried too deep, because I think a lot of these basins that were formed early in the flood, the rocks were hot and the water was very hot. That's probably why you don't find any Precambrian fossils. And I think probably acidic water in a lot of areas too. And as you deposit sand and you buried it fairly deep, not as deep as you think from the geothermal gradient down in the earth, it heated up to 500 degrees and formed quartzite. Then you had this uplift, differential vertical tectonics, where the mountains came up, valleys went down, and you eroded huge parts of this, getting down to the hard quartzite rocks. By the way, quartzite is one of the hardest rocks in the world. Can hardly break it open with a rock hammer. And this is the most resistant rock in the Rocky Mountains. The other rocks are fairly soft. And so in fast turbulent currents, they're going to pulverize, but round the quartzite rocks. And here's kind of the big picture: a sheet flow current hitting the northern Rockies of Idaho, western Montana, and eroding and rounding the rocks. They start off large. By the way, they are large. They're sometimes about that far, that much in diameter there. And then as you get further out, they get smaller and smaller. And they do. We found some in North Dakota 2 years ago that were only about that big. I have found them in central Saskatchewan. They're reported in southwest Manitoba, north central North Dakota. And if they came from central Idaho, we're talking about 1,200 kilometers from their source to where we find them out in here. Now what kind of rivers are going to deposit these rocks and spread them out there? No rivers, no uniformitarian river can explain it, especially when the Continental Divide is right here. All this, the source is west of the Continental Divide, and now they're across it and way out. You find trillions of these rounded quartzite rocks all over these areas. And then as the Continental Divide area came up, the current split. And so you have a water flow going through the Pacific Ocean, and one continues towards the Mississippi River Valley. And so the current splits, and it's taking quartzite rocks from the northern Rockies and spreading them clear to the Pacific Ocean. I have found them quite a bit in Puget Sound area. I'm from Seattle, which is right there. I've even found them near Vancouver, British Columbia. And they're supposed to be out here in the ocean, even though we looked for them for a day and couldn't find them, around Willapa Bay, which is one of these little bays here in Washington. They're all along the Columbia Gorge. They're found on tops of the mountains in here. Anyway, there's a lot of sensational aspects. Anyway, here's where the belt supergroup forms right here. It's from the belt supergroup. And that's the source, generally source of the quartzite rocks. And so here's a plot of the quartzite rocks from northern Idaho, southwest Montana, and Wyoming. These big green areas are thick accumulations. These accumulations occurred in a deep crack in the rock and piled up rounded quartzite rocks. And here east and northeast of Jackson, Wyoming, the quartzites are 11,000 feet thick. And yet, the state geologist of Wyoming says 80% of it's been eroded. So it's probably about 20,000 feet thick at one time. And all this area got eroded, spreading them way out in here. And here's the Teton Mountains right here. There are quartzites on the very top of the Teton Mountains, like right here. We took a 3-day hike up here. And here they are. Here's some of the quartzite, rounded quartzites. The northern Tetons are some of the sedimentary rocks that were not eroded off the upper crust. It's the top of it's limestone, but the rounded, and it's angular, and the rounded rocks are quartzites. The largest one I found is this. Notice how rounded it is from the water of action. Now, how did these rocks get on the top up here? I think it's because they spread first and the mountains came up. So it gives us a timing for some of the mountain ranges in the Northern Rockies. And here's another one on top of the Teton Mountains. And it's interesting that these quartzite rocks, no matter where I find them, I find these semicircular cracks on them. Remember, this is one of the hardest rocks in the world. This is called a percussion mark, caused by banging of rock against rock. We can't duplicate this, so it must have been turbulent fast flow going 100 miles an hour, 150 kilometers per hour, in very turbulent flow, banging up, but some kind of a water cushion to form these. But anyway, the secular scientists agree it is caused by torrential flow, is the way one person described it. And yet these percussion marks on some rocks by the hundreds. I find them all over with these percussion marks, indicating the tremendous pounding that occurred by all this flow of these resistant rocks. And I might add, percussion marks are not forming today on quartzite rocks. Not forming today. It's against uniformitarianism. But it has powerful, it tells us powerful evidence for the flood. And here's a plot of all the ones in Washington State. I've been to many of these. And I want to focus in on, here's one at the top of the Blue Mountains, north of Burns in Central Oregon. And here's a bunch of them on top of the Wallowa Mountains, up to 8,200 feet above sea level. And they're draped over the tops of these mountains. In fact, they're so thick up there that they used to have a placer gold mine on the top of one of the mountains in the Blue Mountains, where they took the quartzite rock and all the finer debris in between, sent it through a sieve to find the gold. There is a lot of gold. In fact, this hill right here is called Gold Hill, because there's a lot of gold that is in with the finer particles in the quartzites. But they had to shut the mine down because it became a wilderness area. Anyway, and oh, by the way, I found them numerous places in the Puget Sound area, even on the San Juan Islands and up here near Chilliwack, British Columbia. And here's pictures. This is 8,200 feet on top of the Wallowa Mountains on a ridge. This is the quartzites right here on the top of this ridge. There's supposed to be one a meter in diameter, but I never found it. It's probably in this snowbank. But this is the largest one I found. The nearest source of quartzites 100 miles to the east across what is now Hell's Canyon, the deepest canyon in North America, even deeper than Grand Canyon, I might add. It's 8,000 feet deep on the Idaho side and 6,000 feet on the Oregon side, and it's about 50 miles long. So you can see some of the finds where the gold is found right in here, but that's the largest. That takes a tremendous current to do that. And look at how rounded and polished it is. And I'm going to the Cypress Hills now. All these planation surfaces and ones I don't show here at lower altitudes are capped by quartzite. And this is the quartzite below this, the gravel of the glacial till, glaciation, out in this blue formation right here. Here's the Cypress Hills. It's capped by 75 feet of rounded rocks cemented together, forming a conglomerate. I'm here on the north edge of the Cypress Hills, looking down at the next planation surface, which is 1,000 feet below me. You can kind of see what it's capped by, rounded rocks on a high plateau, indicating that this plateau probably was very extensive, north and south, east and west, and then it got eroded all around, just leaving the Cypress Hills as an erosional remnant. Tremendous action and evidence of the flood, huge catastrophism. Here's a more close-up of those rounded rocks. There you go. I find a lot of them are iron stained, so this must have been a lot of iron in the water, probably hot water, so that the iron would stay in the water, and it coats a lot of these as a patina on these quartzite rocks. And here's some percussion marks that are really big on this quartzite right here. Here's the big picture. You had currents running off the Rocky Mountains. The Rockies were coming up, and it was eroding all the plains area. And it was eroding the plains. It deposited the quartzite rocks. Now, the medium-sized rocks were carried up in the suspension, come crashing down, forming the the percussion marks. The larger rocks were carried along the surface, eroding the surface down. That's what does the erosion. They call them tools, geological jargon, and they erode the surface. And after the current wanes, it leaves a capping of these rounded rocks. That's how come you have 75 feet of them on the Cypress Hills. And based on civil engineering equations, open channel flow equations, we can put some minimum currents to these. A 6-inch bullet wide rock, which is like this, round and like the shape of a bullet, we figures this is the largest rock carried up in suspension and come crashing down, and implies currents over 65 miles an hour in water depths over 180 feet. So we put some numbers to these things. What is this saying? It's powerful evidence for the runoff of the floodwaters at high speeds, eroding, forming planation surfaces, then eroding those planation surfaces into erosional remnants. Here's a summary of the quartzite. They're spread 800 miles east from their source in the Western Rockies, west of the Continental Divide. They're spread 400 miles west of the Pacific Ocean. Percussion marks indicate torrential flow. Planation surfaces, long spread of quartzites, percussion marks aren't forming today. Powerful evidence for the flood runoff. So this is the last feature I'm going to talk about, and then I'm going to open to questions and answers. I'm going to shifting to phase 5, the more channelized phase, where the water is forced to channelize around obstacles, forming more linear valleys and canyons rapidly. And a lot of times superimposed on the wide planation surface, like a Grand Canyon. You erode the whole area as a sheet flow, phase 4, and then you form Grand Canyon, Zion Canyon, and other canyons in southwest Colorado Plateau during the channelized flow phase. It's a great 1-2 punch, and one superimposed on the other. Exactly what you expect during flood runoff. So I'm going to talk about one landform for the channelized phase, and that's what's called water gaps. A water gap is essentially a gap through a mountain ridge or mountain range or even plateau where the water from a river or stream starts on one side and passes right through a gorge to the other side. They're called water gaps. And in my area, this is north central Wyoming. Here's a water gap right here through the Rattlesnake Mountains. Yellowstone Park is further to the west that you can't see, or maybe this mountain is part of it. But this is a range of mountains east of Yellowstone. And here's a gap, a cut through the mountains, kind of white at the top, and it narrows it to very, very much like Grand Canyon, and that starts out wide and goes very narrow. And this is about 2 miles to the end there. Now, the Shoshone River starts in southeast Yellowstone Park, moves east out of the park, and comes to this Rattlesnake Mountains. Instead of going around it this way, like this, and come out near Cody, Wyoming, it continues east and cuts right through the Rattlesnake Mountains, which are 2,500 feet tall. That water gap's 2,500 feet, cut in hard granite, and the dipping sedimentary rocks. You see the sedimentary rocks dipping towards me, which is east, and there's granite in the center. Here's a close-up of it. Of course, they built a road through it, and in the water gap, they formed a dam. Good place to dam the Shoshone River, and that they did. Here's the water gap right here. Shoshone River goes through there, and here's the dam. Look at how low and wide that area is. The water, when the sediments were a little bit higher, say 100,000 years ago, the Shoshone River was running. It should have easily gone around those Rattlesnake Mountains there, out this way, and drained through the Bighorn Basin there at Cody. In fact, this is so low, they had to form another dam there so the water wouldn't run out. And that's where they get their irrigation water. But the river ended up going through there. Why? Well, they don't know, but they have approximately four hypotheses for the origin of water gaps, which I've analyzed and published, which I'll give you some links on how you can get a hold of a lot more published information. And there's 1,700 water gaps through the Appalachian Mountains, so the ridges of the Appalachian. Here's a famous one north of Harrisburg, Pennsylvania. And this is the first of about 3 or 4 aligned water gaps, aligned in a curve, gentle curve like that. And you got to ask yourself, why did the river end up cutting through these ridges when it could have easily gone around the ridges? Because there are low spots that it just cut right through them. And there's 1,700 of them in the Appalachians alone. So water gaps, there's thousands of them across the surface of the earth on all continents. And I have analyzed them in southern England and in North America, including Alaska, west coast, east coast of the United States. And I've looked in the literature for places in Africa and Europe. They're there. Anyway, the guy did a PhD thesis on the Zagros water gaps in southwest Iran. And then he wrote a book. There's at least 300 water gaps in the Zagros Mountains, up to 8,000 feet deep, deeper than Grand Canyon, which is a long water gap. Grand Canyon is the longest, but not the deepest by far. The Zagros Mountains, the way he describes this is the rivers don't normally go down valleys like they're supposed to. Oh, they do for a little while. Then they cut through obstacles, mountains. And then not only do they cut out, they sometimes come back out. Really strange things. When I read this book, I was laughing all the way through it because they were all uniformitarian conundrums that can't be explained. And here's just one little quote from Thomas Oberlander, who's an expert on water gaps, I might add. The Zagros Mountain drainage pattern is distinctive by virtue of its disregard of major geological obstructions. Disregards them, both on a general scale and in detail, local scale. Certain streams ignore structure completely. Some, I like the wording here, some appear to seek obstacles to transect. Now, what kind of normal river is that? And this is not unusual. This is probably the best example in the world of the craziness of the drainage patterns of the world through water gaps. They can't explain them, even though they wing it. They try. They don't like to leave theoretical vacuum with no explanation. They always have explanations. You look at the explanations and you find out that they don't hold water either. And they're just winging it because they don't know what else to say. The deepest water gaps are in the Himalaya Mountains, where 9 rivers start in the southern Tibetan Plateau and they head for the Himalayas. And the mountains do cause them to, the rivers to form, go down the valleys for a while. Then suddenly they cut right through the mountains in deep water gaps. There's one water gap east of Mount Everest that is 4 miles deep. The Aran River that cuts through the Himalayas into the Indian Ocean. By the way, we have an analog for water formation of water and another thing called wind gaps, which I'm not going to get into. There's a lot of things I can't get into. I mean, I can write a 5,000-page book on all this. We have an analog in the Great Lake Missoula flood, in the Channel Scablands of Washington, my home state. Which I've done a lot of research. I have one book and one DVD out on this topic. For Glacial Lake Missoula, 500 and some odd cubic miles of water by an ice dam in northern Idaho broke and emptied in 2 days and spread through eastern Washington, cutting up into deep canyons, flat bottom canyons called coulees there. And J. Harlan Bretz pointed this out in 1923. And no one believed him for 40 years. And they're all against him, as this quote says. They rejected it because they don't believe in floods this big. It was too biblical, some people said. We just don't believe it, period. until they went out there. And then we had overhead pictures, and we could see ripple marks and gravel and many other features of flood, big gravel bars. But anyway, in the southern part, here's the Snake River right here. So I'm going to jump down to this right down in here. And in the Snake River, which is right here, between the Snake River and this Washtuckna Coulee, the Palouse River used to go down like this. But in the Lake Missoula flood coming down from the north, cut across this 500-foot high ridge and eroded in this area, about 8 miles wide here, and then narrowed down to a narrow canyon. After the flood, the Palouse River, instead of continuing down the Washtuckna Coulee, takes a left-hand turn through Palouse Canyon and into the Snake River. This is where a gigantic Lake Missoula flood formed water gap, as well as a wind gap over here I'm not going to talk about, in a monstrous flood. And here's kind of a summary of this. You had sheet flow transitioning into channelized flow. And so here you got a sheet flow going perpendicular to a ridge. The ridge is probably coming up and the waters are draining. Remember, the waters are draining during all this and the mountains are rising. And no ridge is perfectly flat, so the low areas end up being eroded more than the higher areas. And with time, the tops of this ridge show, and it funnels the water through these gaps. And then when it funnels it through, the same amount of water has to go through a more narrow area that's to accelerate. And the velocity of flow is approximately equal to the fourth power of the erosion. You cause 10 to the fourth erosion with a doubling of the current speed. Erosions to the 10th to the fourth power of the velocity. And here it's going through here too. But then with time, shifting currents, other features that happened during the flood, a lot of chaotic things occurred. And so all the water ended up flowing in deeper and deeper, and this gave up. And so at the end, it formed a deep water gap where the rivers will end up going through. And this left high and dry would be a wind gap, only winds going through it. You find thousands of wind gaps on ridges in the mountains too. So this can easily be explained by the flood, these water gaps. Yet they have 4 hypotheses which have serious problems. So I'm going to get back to why can't mainstream scientists see it? Why can't Davis Young and other geologists that teach on Christian campuses, but teach you evolution and deep time and uniformitarianism? Why can't they see it? Well, I think it's a psychological phenomenon. There's room for psychologists in all this. I picked this up from a book called The Promise of Sleep. Being a shift worker that worked rotating shifts for 30 years, I had sleep issues, so I wanted to know how to deal with it better. So I got this Dr. William Dement book. He was a professor at Stanford University. He was one of the discoverers of REM sleep. He says on page 34 of his book, by the way, you can get quotes from geologists that say the same thing. Even when they are looking, people usually see only what they expect to find, and they do not see what they assume for whatever reason could not exist. So those professors that teach on Christian campuses that got their education at secular universities got essentially brainwashed in uniformitarianism. So they got uniformitarian glasses on. So all they see is slow processes over millions of years. They don't see catastrophism out there, the tremendous evidence for the flood. And I only gave you a little tiny bit of the evidence. It's a psychological phenomenon. They don't believe it exists. They don't see it. Interesting. And by the way, one of the reasons that attracted me to this area is I was a weather forecaster for 30 years in the National Weather Service. And I did this to a lot of people. I ruined probably thousands of picnics and outdoor activities. Today's forecast, 100% chance of sunshine and pouring down rain. But of course, the period of verification is 12 hours, and after the rain goes, you might see some sunshine. So in a way, it could verify. But anyway, tell me why I should trust scientists when they can't even tell about the Earth over millions of years, when they cannot barely forecast the weather. By the way, we're doing a lot better job forecasting the weather, I might add. Computer models are so much better. Anyway, if you want to know more about this is a summary of generally what I said, but more. And that is just a summary too. How Noah's flood shaped our Earth, just kind of an outline starting from before the flood and going through the phases of the flood in chronological order, and then talking about the ice age after the flood caused by the flood. And I've even written for children to explain a lot of this geology, exploring geology with Mr. Hibb. We have one about dinosaurs too. You can get it from Creation Ministries International. And I just wrote a book just recently about the time issue. I didn't get into that here. That's a whole different topic. Lots of problems. It's called The Deep Time Deception, Examining the Case for Millions of Years. So I recommend those 3 books for those that want to search more. But I want to leave you with a Bible quote from 1 Corinthians 2:5. Your faith should not rest on the wisdom of men. The wisdom of men trying to figure out Earth science without God is where they get evolution, deep time, millions of years, and uniformitarianism, all under the aspect that God does not exist. We should not have our faith depend on that, but on God's power. God has the power to create, cause a flood, and all the miracles in the Bible are no sweat to him. If he can create the universe, it's a small thing to create a lot of aspects of the earth and do miracles. And here's some websites I want to leave you with. This is the final slide. Creation Encounters is a group that does tours in the Western U.S. if you ever want to get involved in a tour. And probably most of you heard of these 4 major sites. Creation.com is CMI, Creation Ministries International. That's the one I mainly do my research with, but then there's Creation Research Society also, do a lot of research. And I want to mention my website. On my website, I have 2 free ebooks in color. I have one about 800 pages, I think, going through what I've just talked about in more detail with color pictures throughout it. And it'll give you a lot more information about the runoff or the retreating stage of the flood. Then I got a second ebook on where's the flood post-flood boundary. And I go through about 32 evidences that it's in the late Cenozoic, assuming the geological column, but not any one spot because we can't depend on their precise dating methods. Generally in the late Cenozoic, which is defined as the Miocene, Pliocene, Pleistocene. And every area has to be examined on its own merits. I've seen places where it's probably in the Miocene and other places it's in the Pleistocene, using the geological column as a template. So now I will open it up to questions, and that's the end. And so.
Well, thank you, Mike. Let me remove this from the screen real quick. And I have to say that was looks like you're good. I got to say that was a remarkable presentation.
Yeah, well, thank you.
You're good.
How do I get off?
I think you're. Yeah, I think it's not shared anymore, so you should be good, Mike.
Okay. All right. I gotcha.
Awesome. Let me adjust my mic here. And I mean, just like the title of your lecture there, there's just so much astounding evidence for the global flood.
There is.
It brings me, it's amazing. And it brings me to 2 Peter 3, where the scoffers are willingly ignorant of the world that then was being overflowed with water perished.
Right. Mm-hmm.
I just wanted to say God bless you for all your amazing work and research. You know, I'm not the only one who agrees that I very much appreciate it. And I like the way you ended it. you pointed out that it is a psychological issue.
Mm-hmm.
And as you said, you could literally write a 10,000 page book on this. I've got a couple here that I'd like to recommend as well. Frozen in Time, on the mammoths. That's a great book.
And the Ice Age.
Yes. Yeah, and the Ice Age. This one has been a huge help for me. Rock Solid Answers.
Mm-hmm.
I think you co-authored this. So especially for the audience, we've got
editor on that with John Reed. We got a bunch of creation scientists to give us 14 geological challenges, and we gave answers about fairly detailed answers, and about an average of 20 pages each.
yes. Yes, I felt they were very technical, very detailed answers, and it's a book that I wish everybody would have on their bookshelf. So, real quick, I want to say we've had a lively audience. We've got a ton of questions, ton of great questions. You've answered a lot of questions too, just directly in your lecture and presentation there.
Mm-hmm.
I hand it over to George. I don't want to dominate the mic, George. Maybe we'll have you. You've done a great job gathering the questions, George. Maybe you had a couple comments you wanted to make on the show, and then if you want, you can have the opportunity to ask the first question, George.
Oh, thank you. I'm just going to give you the standard secular sort of answer to this. Sorry, Mike, I'm not convinced. There's no evidence for a global flood. But seriously, I was interested in the mega sequence of the sandstone that you've shown, but there are far larger sequences than that. And I'm referring to the limestone, which effectively there's evidence for it from England through Europe, the Middle East, through to America, and then even Australia. And that sort of leads me to a question that we pose to most of our guests here, specifically John McKay and some of the other geologists that have appeared on our show. They suggest that limestone is predominantly a chemical process.
Mm-hmm.
We've even observed it forming during volcano eruptions.
Really?
Do you have any thoughts on this and how possibly the heat could have assisted in this formation?
Yeah, limestone, let's see, it makes up about 15 to 20% of sedimentary rocks. It's a chemical precipitate. There's a lot of organisms in some limestones, but it mostly looks like it's a chemical precipitate. I must say that right now, since I'm up on all the research, we really don't have a good answer for, I'll say carbonates, because there's more to just limestones. There's dolomite. And I'm thinking that there's so much carbonate there around that I think a lot of it came from below the ground in the fountains of the Great Deep. Same with a lot of other unique chemicals we find, like iron, banded iron formations, chert, silicon dioxide, and iron oxide layers, and also we have unique sands as well as limestones and dolomite. And it's interesting that you have a huge amount of carbonates in the Precambrian, and also dolomite. And we don't really, the secular scientists, I don't think they really know where all this comes from, but I think it had to come from below the ground in the fountains of the Great Deep, because where else could it come from? I think a lot of other chemicals came from the fountains of the Great Deep and explain a lot of these unique Precambrian formations. This is an area I'm doing research on. Dolomite, which is calcium magnesium carbonate. Mostly you find a lot of it in the Precambrian and Paleozoic, and it decreases Mesozoic and Cenozoic, using the geological column as a general template, which I do believe in a general geological column with exceptions. Dolomite, I'm trying to find the conditions of when it could precipitate. Apparently, there is some research, but they all think it's the replacement of limestone at ambient temperatures we find on the surface today. But I think it's a precipitate. Some of these dolomites cover huge areas and can be over 1,000 meters thick. And so it has to be a precipitate, and early in the flood, and mostly, and the temperatures are well over 100 degrees centigrade. I think this is giving us a hint that the early floodwaters, especially in deep basins, were hot, and therefore dolomite formed. And I think even a lot of carbonates would form with these temperatures and temperature changes in the water. So those are some areas I'm working on. But remember, this is all part of the early flood for me, and it tailing off through the flood, and for the carbonates. And so it's a research project that I'm working on actually right now. I'm reading a lot of papers on dolomite, but I'm frustrated because they don't get to the point of exactly what you need. Dolomite is not only interesting in that it's magnesium carbonate, but it's also, you have to have the right proportions of 50% magnesium, 50% carbonate. There's a lot of them that are formed today in tidal pools in southern Australia, and it's called sapkas in the Persian Gulf. But they're formed by microorganisms, help them form. But there's a tremendous barrier for magnesium forming dolomite, a kinetic barrier, as they say. But heating it up 100, 200, 300 degrees centigrade gets rid of that barrier. And not only do you have the barrier, you have an ordered arrangement you have a layer of calcium, carbonates, magnesium, carbonates. It's layered. It's called ordered. And a lot of the dolomite we find is ordered. And that is very difficult to form today. Oh, actually, it doesn't form today. And even in the lab, it's difficult to form without microorganisms. So carbonates are very interesting, and I'm doing active research on that right now.
Well, Mike, I'd like to follow up. In terms of, thanks for that honest answer, by the way, but I'd like to pose to you the secular explanation. They have limestone forming at 1 centimeter to 15 centimeters per 1,000 years. Yet we find it hundreds of meters thick in places, and it's pure.
Yeah.
So when we talk about an honest answer, what is there? You can't sort of argue that is an honest answer, that hundreds of millions of years and all you got was lime deposit and no other sediment mixed with it.
That's a problem they have all through the formations that they talk about, whether they're talking about chalk or thick sandstones. I mean, it's a typical problem in practically every sedimentary formation in the world. So yeah, it's pure. And yeah, they go about 1 centimeter, 1,000 years is about their typical deposition rate. And so we would probably form it by chemical from hot going to cooler water, just dumping all at once out of there and precipitating in big, thick areas is kind of how I look at it at the moment.
Actually, George, if I could jump in there real quick, just because before I forget, this is a question that a lot of people have. So I take all these questions into one, and then I know you had a follow-up in regards to heat, George. So maybe after I ask this, just so I don't forget, you can jump into that question, because I've read some of your work on this, Mike, in regards to the KT boundary. So I and a lot of other people were curious as to your thoughts on the KT boundary and the associated iridium layer. How do we fit this into the global flood model exactly?
Okay, boy. First of all, I don't see the KT as being the flood post-flood boundary for lots of reasons. You can look in my website in that free book. I give you 32 reasons. Tim Clary gives a couple more reasons. So there's about 35 reasons why it's not down there. And I've been actively working on the fossil issues that have been given to me as challenges. For instance, Australian marsupials. And so the KT boundary is, they define it by an iridium layer, but I think, if I recall, I wrote an article on this about 25 years ago in Journal of Creation. I'm thinking that those iridium layers generally, they're probably not at the KT exactly, but they moved the KT to those iridium layers in some cases. And I think there's an iridium layer, and the iridium layers in some places are very thick and they're not thin like they're supposed to be. And they don't find the iridium around the supposed impact in the northern Yucatan Peninsula, the Chicxulub impact crater. And I think you'll probably find, if you'd look, a lot of iridium layers all through the sediments, but they don't look for them because they don't think they're there. So they only look for them around the KT, and then of course they find a bunch, and sometimes they don't line up with it, but then suddenly the KT drops down to where that iridium is. So I think there's a bit of circular reasoning in all this. And I think there's a lot more iridium layers in the sediments than you find at what the supposed KT. Those are some thoughts on that.
So
I think I answered part of your question, but there's a lot of aspects that shoot off from that.
Yeah, that's fair enough. Just because we don't know the answer now doesn't mean we won't find it, which is what they tell us a lot of the times when we ask them the tough questions. But Mike, we constantly hear this argument from many of the critics. They will frequently avoid answering all the astounding lines of evidence for a flood by pointing to a heat problem, which you've probably heard before. So
Yeah.
what are your thoughts on this common criticism of the global flood? And I'm curious, does your theory of vertical plate tectonics have a solution to the often mentioned heat problem?
I think all flood models have a heat problem. The one I lean towards is meteorite impacts, probably about 1,000 of them, followed by differential vertical tectonics, and that drains the floodwaters. But there's problems with that model. I'm doing a little bit of research here, off and on it. But I do see evidence for catastrophic plate tectonics too. So I favor that about 20%. And I see. Since I read the current literature and even the old literature I've been reading for years, I find tremendous problems with plate tectonics that no one hardly knows about. Yeah, they sweep it under the rug, but we need more research on that. But there is evidence for it. And there's evidence for impacts. They claim there's about 200, actually 190 is the last I just looked here a few days ago. But I think there's evidence for many more that they ignore because their criteria is so stringent. So with catastrophic plate tectonics and impacts, we do have a heat problem. This is acknowledged. And at this point, we haven't got a good solution to that. Now, Russ Humphrey's working on some exotic idea about the expansion of space absorbing the heat, but I don't know. I'm kind of unsatisfied with the little bit I know about that. Another one is that, God's in control of the flood. You got to remember, Psalm 104, 6-9, he started the flood and he ended the flood. And also it says, I think Psalm 22, is it? He sat as king of the flood. He was in charge of the flood. So I'm assuming he took care of the heat problem. I'm giving it in God's hands. Now, people might think that's a cop-out, but that's a result of a lot of thinking on this. And we actually do have some evidence of that in the form of pleochoric halos. The work of Andrew Snelling indicates that plutons cooled dramatically in a matter of days. In other words, we had some kind of rapid cooling of the heat. And if that happened for plutons, which are big granite masses, it can happen all over the world. But I'll tell you, the secular scientists won't accept that. But we believe in a God that is all powerful, and I have no problem with it. I mean, if I could find a solution to it, I would. But all flood models have a heat problem. I readily admit that. Even the one I lean towards, and which is the impacts followed by differential vertical tectonics. So that's about all I can say on that.
I like to point out, Mike, and that was a great answer, great responses so far. I like pointing out the fact that heat is necessary for the flood, as in heat and energy are required to get the plates moving in the first place. So the point I'm trying to make is the heat it's not really a bug, it's an actual feature of the flood.
Right? Yeah.
And we don't necessarily know the temperature of the Earth's core in the pre-flood world. So a lot of that heat and energy may be in the core right now. So
yeah, there's one idea out that the heat ended up down deep in the mantle and the core and heated up the Earth. That's an idea worth pursuing.
Right.
Yeah, I just don't know how it'd get there though. But I'd have questions on that. But that's a possibility.
Right. Great answer. George, did you have anything to add, or did you want to move on to one of these other questions we have here? I've got a bunch I can. Well, I'll say this, because once again, there's a lot of questions that I can kind of just take, Mike, and just fuse into one. And this is a common question that people have, and I know you're no stranger to it. So what is the best explanation for the ordering of the fossils in the so-called geological column? Because we know that the evolutionists will say that the ordering reflects evolutionary history, right? From simple organisms to man and more complex organisms. So what's the best explanation for that ordering, do you believe?
Well, first of all, you can challenge the evolutionary idea of going from simple to complex, and that nothing is simple. Every organism is exceedingly complicated, and you go from exceedingly complicated to exceedingly complicated. You might think that there might be a little bit of transition there from bacteria up to single-celled up to man, but even the lowly trilobite at the very bottom in the Cambrian, as well as in the Paleozoic, its eyes are compound eyes, hundreds of lenses, double lenses that have to focus underwater. Their eyes, some people have said, are more complex than our own. Right from the beginning, and trilobite has no ancestors in the Precambrian leading up to a trilobite. It suddenly appears there, similar to all the other organisms and the gaps in the fossil record that indicate creation and the flood. So we can challenge them on a lot of aspects of the fossil record. As far as us explaining it, which, by the way, the Lord has led me over the years to not necessarily bash evolution, which I found easy, but to answer challenges that they give to us. So in that, I go along with generally what most creation scientists have surmised is due to ecological zonation. Vertical for one thing. You find a lot of bottom organisms first, and then fish, and then you come to the terrestrial organisms, which is a flood that affect the deeper ocean parts and come up and over the land. So there's a vertical ecological zonation in there, which makes a lot of sense. I think there's also a horizontal zonation, which I don't think too many creationists have thought of, that in one side of the earth you had maybe a unique ecosystem versus on another side, and that got buried at the same time, we'll say. But yet, because they're different, they would be put in different slots in the geological column. See, the geological column looks good on a local or even regional scale, but when you talk about a global scale, that's where you run into a lot of glitches. And so, for instance, flowering plants, they don't show up until the Cretaceous. And then you got to say, where were they in all that time before that? Well, it could be that they were deposited just as early as some of the older plants, the ones, the Carboniferous coal ones, but in a different area of the earth, a horizontal zonation. Nobody's really worked on that too much, and there's a lot of things that could be explained by that. Diatoms aren't seen in the fossil record until I think about the middle Mesozoic. Where's all the diatoms that should be there before in the Paleozoic? There's none. There's radiolaria and there's foraminifera, but no diatoms. So this could be due to horizontal zonation. So these are areas of research. These are areas to explore. And so I would say mostly it can be sum it up mostly by vertical zonation. Some of the more exotic aspects of the geologic column by horizontal zonation.
SFD, can I ask a question?
Yes, actually, I want to say one thing there, and then I'll yield to you, George, because that was a really good answer, and I would agree completely. And I like how you pointed out that when it comes to the whole simple to complex, they are oversimplifying it because that's not what we actually find. When we go to the first layers with an abundance of fossils in them, you know, we see no fossils and then layers with every one of the body plans of the major division of creatures and animals.
Right, and even more than are extinct.
Right,
Yeah.
right. So I liked how you pointed that even a trilobite has a very complex lens system, and there's nothing simple about that. So,
right.
Yeah, great answer, great answer. I apologize, George. Go ahead. You can ask
no problems. Just to give you an idea of the power of suggestion, all the talk about water and floods, I had to run to the bathroom for a few minutes, so I apologize. But Mike, I thought this was a good question from the Fifth Trumpet. He says, what date are you putting the world being destroyed by water using science? I think he's referring to the 4,500 years ago that the flood occurred.
Yeah, I'm just going along with Brian Thomas's article in the Journal of Creation, where he looked at it in pretty good detail, and based on the Bible, the flood was 4,500 years ago. So I think I've been using that ever since.
If I could jump in here real quick, actually, George, because we got what's called a super chat. So people will spend some money to ask an important question. And I want to get this in here because we've got a lively chat and I don't want to miss it. So I'm going to pop it up on screen. Sigi Fredo Sarabia, hopefully I'm saying that right. $10 super chat asks you a question, Mike. Says,
I see
I'm
it.
a heart. Oh, okay. As long as it popped up.
Is it a flat globe? Now, we're not getting into the flat earth issue, are we?
No. So apparently, is that the question? Is it a flat? Okay. So, I mean, that's an easy answer. The answer is no.
Right. In fact, if you want to know more about it, I would say check out Danny Faulkner's articles on answersingenesis.org website, and he counters a lot of this. And I see a lot of evidence against it. It just can't be. And no, if we're talking about the flat Earth, it's not flat. It's not the flat Earth. It's a globe. Sorry,
right.
I hate to be blunt.
Mike,
it's a simple answer. Go ahead, George. I apologize.
Yeah, Mike, if I can add to your answer regarding the science of the flood, I think SFT has done quite a bit of work. So has Dr. Jensen on when it may have occurred using genetics, and we've looked at haplogroups, the study of mitochondrial DNA, Y chromosome.
Mm-hmm.
Which is further evidence for the flood. Correct, SFT?
That's right. That's right.
Yeah, I've only looked at that a bit, and since it's in biology, I kind of miss the details of it, so I'm really not in a position to get into that and very, very well. He's finding some interesting stuff, and he's related it to possibly the spreading out of the people from the Ark, and there's I found some good stuff there, but I have not delved into it too deep. So at this point, being a non-biologist, I'm gonna have to say, hey, there's a lot of understanding I need to catch up on before I can really get into that.
That's fair enough.
That's fair enough. I've got a question here from the audience based on some of the things you were saying, some of the research you've been doing. Question, what's the most shocking thing you have found, Mike, in terms of fossils?
Fossils. See, what I've done most of my study in geology. I've been studying it for 45 years. Fossils are to me an incidental. Sorry, but shocking fossils. Let's see. I've seen a lot of dinosaur tracks. They're rather shocking in a way that, and I've seen dinosaur eggs, dinosaur bone beds, and there's a shocking aspect to all this in that people ask, well, they're live animals, and they have to be dead by day 150. So how do they make tracks and lay eggs on in the chaos of the early flood? That's a challenge we get, and now they find millions of these tracks and eggs, by the way, all over the world. And as a result, it was I think John Morris said once that he thought it was one of the most challenging pieces of earth science that one of our most challenging areas. So I spent a lot of time working on it, especially since I'm in dinosaur area right here in Montana. So I came out with the beds hypothesis, briefly exposed diluvial sediments, which I wrote in a book and several articles, where you find these shocking features in areas where there's thick sediments, like around Moab, Utah, very thick sediments. And then you have evidence of huge erosion above that based on erosional remnants and rhododendron anticlines, the rank of coal, and other indications of the amount of overburden. So the beds hypothesis works in that they're in areas of rapid deposition. And so as the bottom of as rapid deposition, here's the floodwaters here, and you're depositing more and more. And finally, the floodwaters become shallow. And the floodwaters aren't just a general rise and fall. They're going up and down like this based on tides, for instance, twice a day, and other features of tectonics. And so you have a sudden drop. And here you have this level, the bottom of the floodwaters exposed maybe for 100 miles. And you have creatures floating in the water or on log mats or from higher ground, the dinosaurs mainly that get out on those, lay eggs, make tracks, scavenge bone beds to leave their teeth in there, damage bones from their teeth. And then the floodwater rises and covers up all that. So it's called the beds hypothesis, and it's written in a book, Dinosaur Challenges and Mysteries, which you can get from Creation Ministries International. So that's probably the most shocking fossil feature that I've run into, and I think I got a good hypothesis for its explanation.
Mike,
I do find it interesting that you oftentimes find the tracks before you find the actual animals associated with the tracks.
Often, but not always.
Right. I also find it funny, based on what you're saying, these fossilized footprints or dinosaur nests, raindrops, which I feel would indicate rapid burial. But I've heard the critics use the argument that the fact that we find these things, for example, dinosaur nests with eggs, they say this is evidence against the flood, because apparently the flood would have destroyed things such as dinosaur nests. Have you heard this argument? I mean, what are your thoughts on that?
Yeah, I've heard that argument, and I've looked into it. First of all, there's hardly any real nests out there.
Mm.
I've actually seen nests where you find a depression with eggs in it on Egg Mountain, about 150 kilometers north of where I live. And that's one of the few nests in the whole world. Nest is defined as a depression or an area where you find evidence of vegetation placed on it. So you see very few nests. And I'd say you find less than a dozen re-nests. But the thing is, this is a tricky area because secular science define a nest as a group of eggs. That's a nest by definition. Or eggshells. They find an area, a bunch of broken eggs or eggshells. That's a nest. Oh, no, that's not a nest. It's just a clutch or eggs. Practically all eggs are laid on flat bedding planes. And the problem with that, with no evidence of vegetation over them and not in a hole, except rarely. And I've seen the one major exception on Egg Mountain of a real nest with eggs in it. The problem with that is dinosaur eggs are very porous. And so sitting out there with no vegetation on it or not buried in a hole, they're going to dry out rapidly. And so I see this as evidence of dinosaurs laying eggs in a hurry on beds, briefly exposed to alluvial sediments, just on flat bedding planes, because they didn't have time to dig a hole. And they were swept off this area as soon as they laid the eggs. And then this whole area was covered up with muddy sediments to be preserved to where we see them today. See, preserving all this stuff is a major problem in the evolution, in the uniformitarian literature, because they like this, they believe in about 1 centimeter or 2 centimeters of deposition every 1,000 years is their general average rate of deposition. And so at that rate, how are you going to deposit all this material and preserve tracks and eggs with a deposition that slow? So they have lots of problems. And that's one of the reasons when I looked at the raw data, when I developed the beds model, and I do have evidence for that model, and that's one of them, the eggs laid on bedding planes.
Mike, coming from an engineering background, we've studied earthquakes and the effects of earthquakes, and you've probably heard of liquefaction.
Yes.
You can even do the experiment at home with sand, get an arrangement of eggs similar to how the dinosaurs would have laid their eggs, shake it, and it acts like a quicksand. The eggs will literally sink below the surface, and that would really maintain that structure and shape that the dinosaurs would have originally laid their eggs in. That's the way I explain it. I explain it through liquefaction.
That's a very good hypothesis. Yes, that's a good one.
Yeah.
I'll remember that because I hadn't thought of it.
That's why we pay George the big buck.
You can use it, Mike.
All right, thank you.
One thing I'll say, or a question that kind of came to mind, is we always hear the critics saying that young Earth creationists, flood geologists don't make any testable predictions, future testable predictions. How best to respond to this claim? And is it erroneous? Do young Earth creationists make testable predictions in terms of flood geology, the global flood?
Well, you got to remember, I was in the business of future predictions for 30 years. They paid me good money to be wrong. My weather forecast.
Right.
I'd say none of us really make predictions because this is in the past. If anything, they're what's called post-dictions, or what's that the term? Post-dictions. Anyway, they can make predictions on what you'd expect based on their model. And we would expect, we make predictions. We would expect layers laid over huge areas, and then the next layer laid flat on top of that, one after another in quick succession. And that's exactly what we see in the sedimentary records. They would say it all is formed by 1 or 2 centimeters per 1,000 years, or maybe it might occur rapidly in a catastrophe along a flood and on a stream. But you look at the sediments in that, and nowhere near matches what we see in the rock record. Nowhere near, because it changes facies, as we say, different types of sediment in short distances, horizontally and vertically. That's what we see with floods today. But that's not what we see in the rock record at all. We see these huge formations over huge areas with little or no erosion between the layers. And they give them tens to hundreds of millions of years to lay down these layers at 1 to 2 centimeters every 1,000 years. And where's the evidence of erosion? See, their predictions could be falsified when we look at the bulk sedimentary rocks, which is where they claim that you can see evolution, versus we say they're deposited by Noah's flood, and this is what we should expect. And also we should expect billions of dead things in rock layers, buried in rock layers all over the world, and that's what we see. And their fossilization today, based on uniformitarianism, is extremely rare. You got to bury it rapidly under thousands of feet of sediment to get enough chemicals and depth to get the groundwater moving and replace the organic matter with chemicals, silicon dioxide or calcite, for instance. So we can make post-dictions, plenty of them, and they can, and I'd say we could verify a lot of our post-dictions.
Now, Mike, this comes from an atmospheric science point of view. Okay, we all know about the Lost Squadron, but
yes.
one of the questions is: do ice cores contradict biblical history?
I have a whole book on that you can get from ICR, examining the history of the Greenland and Antarctic ice sheet. I think is the title of it. Yeah, I go through all that. Like I said, the Lord's led me to lead challenge, and that's a challenge because they've made a lot of claims about those ice sheets. They're millions of years old. We can see annual layers in them, in the Greenland ice sheet down to 110,000 annual layers for 110,000 years. I'll tell you, that's a deep, long subject to take me a long time to go through it. But and then they claim there's 8 ice ages in what's called the dome sea core, based on oxygen isotope wiggles. There's just a lot I can say, but I'm trying to think of how to summarize it.
Buy the book.
Well, by the book you can get it in detail, but the annual layers, yeah, they're annual layers at the top. Right, we agree with that. But when you get down in the ice where it's compressed, pushed down and spreads out laterally, everything becomes thinner, and you have problems with diffusion. And then assuming what an annual layer is, see, they make an assumption what an annual layer thickness should be before they make a prediction, and they base it on that the Greenland ice sheet's been in equilibrium for about a couple million years. Antarctic ice sheet's 15 million years old, supposedly. It's when it's equilibrium, but it started 40 million years ago, or 35, something like that. And they would say, well, based on that, the annual layer should be about, well, let's see, about that thick of ice at the top. That's about right, 22 centimeters. And then as you get down, they get thinner and thinner and thinner until they're paper thin. They're about as thin as a dime by the time you get down to the bottom. You can imagine it might be kind of difficult to figure out an annual layer at the bottom, but it's that assumption that is locked into how they analyze these ice cores. And what they're measuring when they get down compressed, they're looking at storm layers, because storm layers oscillate back and forth in all these variables. And if you have a thick annual layer, from our model, you don't diffuse those storm layers out. They're still there. And so we believe they're counting storm layers and intra-storm layers, things that happen within storms. Storms are complicated. They're just not a simple, like oxygen isotope ratio. Got the warm sector that with one type of ratio and the cold sector with another, but yet there's things in between that go on. So to upshot, they're counting storms and substorm layers as they get deeper, maybe about 1/3 down. Then they start getting into trouble. And but only the top 1/3 is only about 1,000 or 2,000 years anyway. So it's that deeper part. And so their assumptions kick in, equilibrium. And so that's how they do that. And as far as Antarctica, what they do is they assume the Milankovitch mechanism of the ice age, or the astronomical theory, and that cycles every 100,000 years. And they date deep sea cores that way, assuming that. And they go from deep sea cores, the wiggles in deep sea cores, to the wiggles on the Antarctic ice cores. So it's mainly based on assumptions for that. So I don't know if anyone understood any of that, but you're going to have to get a book. It's or I got articles on the websites about it, creation.com and answersingenesis.org have some articles I've written on ice cores. And Jake Hebert of ICR is working on a lot of details that I just broad brushed in the past of ice core buildup in the flood modeling. So you'll see a lot more stuff from him on that coming up. He's just starting to publish.
I'll add as well, and that's a phenomenal answer. Very good, especially on such a deep topic where, like you said, you can write an entire book on. So in a short answer, that's not always easy. But the book I'm holding up of yours, Frozen in Time, you have an entire chapter on this too.
Yeah, I have one chapter in that, but then I have a whole book, and I'll just. Frozen record.
Right.
Frozen record. Okay.
You can get it from ICR by print on demand still.
Awesome. I'm notorious for ordering books all the time. My wife knows there's always a package coming in the mail, so that'll probably be my next one.
Same with me, yeah. Can I ask a next question in SFT?
Go ahead.
But I'm gonna introduce Mike to one of my theories. Mike, do you know what caused the extinction of the dinosaurs? Just say no.
Okay, this is a joke. No.
They tasted too much like chicken.
Yeah, everything tastes like chicken. Rattlesnakes,
All right.
rabbits.
Now, Mike, here's my question. This is a serious question. How do you best explain the big 5 extinction events in the young Earth creation worldview geochemically?
Geochemically?
Oh, that's the question. Yeah, that's what I've got.
Well, first of all, I think a lot of those extinction events are partly based on circular reasoning. Remember, I said partly. Why? Because they've dated a lot of layers by fossils. And so if you have a vertical sequence, you find one type of fossil in one layer, but different fossils above it. And in between, automatically would be an extinction event. And so when they have these major changes like Cretaceous to the Tertiary, there's different organisms there. So automatically it becomes a major extinction event. And there's lots of minor ones all through the geological column because different fossils are in different layers. So partly of circular reasoning, let's say the Permian Triassic boundary, it's because you have trilobites clear up to the top of the Paleozoic there in the Permian, and then none afterwards. And and then you find different organisms, more land organisms, dinosaurs. So you have a major gap in there. So yeah, it would be an extinction automatically.
Well, Mike, they can't say one extinction event because that'll look too much like a biblical flood scenario. So that's why they have to have like more than one extinction event.
Yeah, 5 major ones.
Yeah.
Now lots of minor ones.
Now, when we were talking about canyons and whatever, I'm sure you've seen the canyon on Mars, supposedly described as of biblical proportions on a planet that has very little liquid water. I find that ironic.
Yeah, it's interesting you would mention that, because I was going to write a perspective article on some new information about the channels on Mars for Journal of Creation, and I got going, and it got so long that I'm going to make it an article. And so I ordered a book, The Surface of Mars, that to learn more about the surface features, so I can fit all these things in. Yeah, I've done a lot of study on Mars. I have, in fact, the stack is right down there. I just looked at it. About half a foot thick of papers. And I think I got a good idea on that. As far as you're talking about the I forgot the name of that deep canyon.
Mariana Trench.
Yeah, Mariana. Well, no, not the Trent. The big deep canyon on Mars.
Oh, Mars. Sorry,
That
I
is
don't know what they've named it.
Marinara or something like that. Anyway, it's very interesting, and I haven't really looked at the origin of that yet. But the channels look like the channel scablands of eastern Washington, but 100 times the size. And this Marinara Canyon is 100 times the size of Grand Canyon. And I think about several thousand kilometers long. I mean, it's monstrous. And then they got Tharsis and Olympic Mons volcanoes that must be 10 times the size of volcanoes here on Earth. And they got a huge amount of meteorite impacts. So I'm thinking that the impacts and the volcanism occurring at the time of the Genesis flood due to a big impacting event released groundwater at a catastrophic rate to cause the flooding of those channels. That's my hypothesis. And I think I have a lot of evidence to back it up, and need to go into it in detail. And that's what caused me to have such a long article. And you're just talking about something that just happened a few days ago. It's interesting you mentioned that. It doesn't excite me to talk about Mars, but it could tie into the timing of the flood too, by probably one big impacting event over the whole solar system, I'm thinking. And so the flooding on Mars would occur at the same time as the Genesis flood. Anyway, I'm telling you about hypotheses I'm working on right now, and they can change with time. So don't take my word for what I said, which is speculation or hypothesis.
Well, that's what science is all about.
Yes.
And I will say this, Mike, we've been going 2 hours and 10 minutes, and you've been so generous with your time and the Q&A. There's been a lot of technical, in-depth questions. So I don't want to keep you any longer. This has been really, really good. And I'm probably going to be re-listening to it tonight, because you gave so much good evidence during your presentation and some great answers. So let's not keep you any longer, since we've been going quite a bit. And what I can do is, we've got questions for probably the next week, Mike. So I could I'll save those maybe for another day. If we ever get the
or you can send me some good ones. I'd be interested in seeing what people think.
I will say this, maybe this will be a good one to end on, because you did answer this in your opening, but a lot of people have kind of just got here, and it's a question that has come in quite a bit. So maybe we can end with this one. We'll end on a good note.
Okay.
And it just came in again. So let me scroll up and find it. This seems to be a question that a lot of people are curious about. And here it is. The chat's lively, so if I don't get them in time, I lose them. But here it is. You did answer this at the end of your presentation, but maybe if you wanted to, you can add a little bit to it. But the question is, ask Michael Oard, where, in your opinion, from your research, everything you've studied, and you're up to date on the evidence too, where do you believe the flood boundary is roughly?
Well, the pre-flood flood boundary, I think the pre-flood includes below the Precambrian sedimentary rocks. So I'd include the Precambrian sedimentary rocks as part of the very early flood, deposited in deep basins that sometimes came up afterwards by rebounding to form mountains. A lot of these Precambrian rocks are in mountains now. Uinta Mountains, the Northern Rockies are Precambrian. And so I'd include them. So the pre-flood boundary would be below the Precambrian sedimentary rocks. Now, the post-flood boundary, I've done a lot of work over 25 years, and people could check my website. And it's under the drop-down menu of models. It's the fourth one. The runoff of the floodwaters is the third submission on there. And I've developed about 33 criterion for where it's located. And based on all those criterion, and I'll give an example here shortly. I put it up in the late Cenozoic, defined as the Miocene, Pliocene, Pleistocene of the geological column. And we can't use the geological column a precise place because I especially think the Cenozoic is all messed up as far as time-wise in the biblical creation model. And I've actually published a fair amount about that. So we cannot take like the Pliocene, Pleistocene boundary. And Pleistocene doesn't necessarily mean Ice Age, because there's some places where there's a few thousand meters of Pleistocene sediments, like the South Caspian Basin, for instance, several thousand meters of Pleistocene sediments. So those are not from the Ice Age. That's flood deposits. And in some of the deep valleys of Southern California, the Imperial Valley, the Santa Clara Valley, the Los Angeles Valley, you have deep basins in there that are filled with a lot of Pleistocene sedimentary rocks. So that's not from the Ice Age. So I have found in some areas that the boundaries in the early to mid Pleistocene in some areas, like the high plains of the U.S. I said that every area has to be examined on its own merits, because we cannot take a line in the geological column as this is the boundary. We can't use their structures. We got to go on our own merits. And that's why I've developed 32 criterion. Actually, I missed one. There's 33 criterion for where to locate it. And when I use that criterion, practically always find it in the late Cenozoic someplace, often in the early Pleistocene in places, but not always. So let's give an example. A good example is coal. Coal is the amalgamation of material from log mats that is beached and then sediments put on it and pressed down and forming coal by the heat. And coal has to have a fair amount of overburden to press it down. It depends on the rank of the coal. Like bituminous coal, you need about 2,000 to 3,000 meters of sediment on top. So if you find bituminous coal at the surface, you know you've had 2,000 to 3,000 feet of sediment put on it and then eroded down to it. So when you find coal, that is obviously a flood signature. I don't think there's any coal that I know of forming today. There might be in some local area, but as far other than that, it'd be very rare and isolated. But other than that, I'd say it's not forming at all. So if you find coal, that was to be a flood signature. Well, we find coal, lots of coal in the early tertiary. We have a lot of Miocene coal in Southeast Australia. We have Eocene coal, that's early tertiary, in the Powder River Basin of Montana and Wyoming. In fact, 40% of the energy of the U.S. comes from the Powder River Basin, which has seams that are up to 80 meters thick of almost pure coal, and yet they're dated early tertiary. So the flood boundary would include that, and that puts it up into way up in the early, the late Cenozoic or the late tertiary. or Neogene for the Europeans, up there in the Neogene, way up there. In fact, you can almost say practically all the hard sedimentary rocks below our feet are from the flood, is what I've mostly discovered. So based on criterion like coal and erosional remnants, planation surfaces, quartzite gravels transported long distances, and many other features, not only from geomorphology, but also from fossils, fossil fuel, the volume of sediment. We have a huge amount of Cenozoic sedimentary rock, climatic data, nuclear winter, volcanic winter, things like this. These are criterion that obviously shows it's in the late Cenozoic. And I've written a lot of articles on it. Journal of Creation has a lot of articles on this subject by me. So I have actually researched it, and I have criterion to pinpoint it. And I've actually went to 3 or 4 areas to work on to pinpoint it. I must say that some areas are very difficult to pinpoint it. I don't want to simplify this, but most areas are easy, but there's some areas that are difficult to pinpoint it. And so I've done this in a lot of areas, mostly in North America. So that's where I put the boundary. And so it would generally include practically all the hard cemented sedimentary rocks from the Precambrian up to most of the late Cenozoic sedimentary rocks. So that's would be flood rocks, and that's based on research for all this. So I can back all this stuff up. And Tim Clary of ICR, I agree wholeheartedly on the location of it.
Well, I can attest to that, Mike, because I've gone through all of your articles on CMI, and you've looked into this extensively, and I really like your points and your criteria. I think your arguments are really strong and powerful and evidence-based. And I like the way you challenge, because I know there are some other people in the young earth creationist camp who might propose the KT boundary as the flood boundary, but I think
mainly on fossils. And I've worked on that. I got a 4-part article that I sent into CMI just recently, including the Australian marsupials and some of the stuff about North American mammals. But so I've worked on it. They've challenged me. I'm working on it. But I expect people who believe the KT boundary to work on the challenges I've given them in geology and in fossils and geomorphology and tectonics and climatology. And it's interesting. Nobody actually tries to counter those arguments. I'm kind of funny. They almost seem like they ignore it. I'm just
I've
kind of
noticed
baffled.
I've noticed that. That's why your arguments and your reasoning are lines of reasoning are very powerful, because I don't really see anybody addressing the geology. Do you think it comes down to, because like you said, it comes down to the fossils as to why some people put it at the KT boundary?
Fossils. So
is it coming down to the interpretation of that boundary as to whether or not it is the result of a comet, possibly, that the secularists look to? I mean, because I've seen some creationists say that maybe the iridium layers has to do with massive volcanic activity, possibly during the flood, that can result
possibly, but I don't think so.
Okay.
Probably our impact debris.
Okay.
And like I said, I think if you looked, you'd probably find iridium layers in a lot of places, and some of the places you do find them near the KT are maybe 4 meters thick. I mean, they're too thick to be a thin layer. They claim it's a thin layer of dust that spread from the Yucatan Peninsula all over the earth, and should have been a thin layer. So, like I said, some of it's circular reasoning. Remember, I said some, partly,
Right.
and some of it's because I think you'll find iridium layers in a lot of different places besides the claimed KT boundary. Now, one of the fossil arguments was done by Marcus Ross, where he said that for the Cenozoic mammals in North America, It's not likely that a mammal spreading out from the ark would come to their exact location of where their ancestors are found in the Cenozoic, buried in sedimentary rocks. A reasonable argument. I've looked at it, and I actually, that was one of my 4 papers I've submitted. There's some problems with that. First of all, those mammals that you find either that are post-flood, come from the ark, or are from the flood in the Cenozoic, they're not unique to North America. You find some of those same mammals on other continents, both flood and post-flood. So it's not a unique situation where you find only certain mammals in the Cenozoic that are claimed by me to be flood, and then the same ones, their ancestors on top of them, in the same locations. No, it's not like that at all. It's a lot more complicated, to the point where it's really not much of an argument at all, as I will point out in that argument. It was submitted about 3 weeks ago, so it's going to take a long time. Some of these articles take a year or 2 to make it through the peer review. Oh yeah.
Wow.
Peer review and so forth, and to get published. So I'd say my average time is probably about, for an article, not a prospective article, even those, maybe about a year and a half average.
Wow.
So unfortunately, you won't see the results of this work for quite a while.
Well, I guess that means you're at least getting a lot of critical feedback and people are taking it seriously. So by the time it does get accepted and published, you know that it's based on some solid evidence. And you've got so many articles on CMI, which means they're all over the place, which means you've spent a lot of time writing, sending it in, and then waiting to get them accepted. Because I want to recommend to the audience, just go to, for example, creation.com, just type in your name, and the amount of articles that'll come up will keep you busy for forever. So I want to say, great answers, great technical answers. Everybody in the chat's loving this interview. I'm gonna yield the mic, and George, I'll give you the last word if you want to. We'll kind of wrap things up. We're now going on 2.5 hours, although 2.5 hours has flown by. I could probably talk about this stuff all day, to be honest with you. George, any final words there, brother?
Yes, we're big on critical thinking on this channel, Mike. But what I'd like to do, I'd like to put you on the spot now. While we're on air, live, and we've got 100 million viewers, I'm going to ask you whether you can come back in a month or 2 specifically to talk about the Ice Age. I think many people would be very interested in that. So the spotlight is on you, Mike.
Yes, I'll do it. The Lord has led me to do things like this, not only to try to answer challenges given to me, but to get the word out as much as I can. So yes, I take this as a high priority to talk to people about these things.
Okay. So,
by the way, speaking of research,
yep,
I still feel like I got 500 years left to go. There's so many pieces of research I can do. I have 15 projects I'm involved in right now, and I feel overwhelmed sometimes. And there's a lot more I can do that I haven't even touched. So for those people that don't have answers to particular questions, I must say that it's because there's not enough researchers out there to do the research, and I don't have enough time in the rest of my life to do 500 years worth. So, but you have to have patience. There's a lot of answers that are out there. So that's what I'd like to, and I'll come back and talk about the Ice Age for you coming up.
That would definitely be an honor. Yeah.
And Mike, feel free to use some of those solutions we suggested, but make sure you say you got them from that fantastic YouTube channel, Standing for Truth.
Okay, I like to give credit where credit's due. And if I ever use that one about the liquefaction for the explanation of, say, as a possibility for dinosaur eggs in troughs, which are hardly any are, I'll give you credit, George.
Good,
Hey,
good
there
on
you
you,
go,
Mike.
George. You're famous. You're famous. Yeah.
Standing for truth. Okay.
And the last thing I'll say is based on what you were saying, Mike. I always point that out too. Is we don't have enough hours in the day. All the different, even for us, for me, it's difficult because I've got the books, young Earth creation books on geology, biology, genetics, astronomy. You know, from all of you men of God who've done so much to defend the faith. So it's hard to choose on a daily basis. You know, what am I going to read today? What am I going to study today? So that's why it's such an honor to have someone like you on today, who's so well versed in these topics of flood geology, for example, to help us out, because this has been incredibly informative for myself, for the audience, and I think I could speak for George as well. So the last thing I'll say is thank you again, Mike, for your time and your presentation today.
I second that, and I hope and pray to God that He gives you the time and the years to undertake all that research, Mike. God bless you.
Thank you. It's a privilege to talk to your group.
Good on ya.
Awesome. Well, thank you so much, Mike.
That's good on you.
Yeah.
Good on ya.
I like it.
It's nice that we could throw in some humor within all the technical stuff. So,
Oh yeah, you gotta have some humor.
Laughter's the best medicine. Maybe it'll keep us living till 500, 600, 700 years old, like our biblical ancestors, and therefore we can get more research done. So,
there's research saying you can live maybe 5 to 10 more years that way.
Maybe not another 300 years. Okay, yeah, awesome. I'm going to shut it down here, unless you had some final words, Mike. Thanks again for doing this.
No, you're welcome. It's a privilege.
Can I finish off by someone, when we were talking about trenches, someone mentioned the Marinara Trench. Because I have a pizza every Friday, I'm going to order a marinara pizza.
Ooh,
such a thing? I suppose in Australia, maybe.
Yes, that's a name for a seafood pizza.
Oh,
it's another planet over there in Australia.
Good on you, Mike.
Okay.
It's been fantastic to talk to you.
Okay, good on you too. I like the expression.
Yeah.
Okay, guys. God bless. I'm glad that we had a nice, solid audience that stuck with us for 2.5 hours. And thanks again, Mike. And thanks for answering some very sometimes technical questions that require, like you've said, 10,000 books on this. So guys, thanks for tuning in. This has been awesome. Share around, please. We want to get this information out to as many people as possible, because this is the truth, and the truth is important. So everybody, Standing for Truth is out. God bless.
Goodbye.